So what I'm going to do is I'm going to share the videos. I have the links here. Yes. And I'm going to start with team. So team number 7, right?
Yes.
Yes.
Okay. Network Science in Medicine for Heart Disease Profiling, right? Henry and Santiago?
Yes.
Yes.
Okay. Let me just share. Hold on. Somebody's trying to rejoin the session. Just please hold on a second. Okay. Let's turn this off. We'll get started then. So, you're already full screen? Yes. Okay, so how this is going to work, right, Professor, is we're going to play the video and then we're going to have a discussion for each report, on each report. So,
Good evening. We are going to present the progress report for the Network Science in Medicine for Heart Disease Profiling project. We are Santiago Rodriguez and Henry Percy. What is our project goal and scope? We want to target specifically a cardiovascular disease profiling. We want to eliminate some overlapping treatments based on symptomology and use network science as a support tool in medical decision making. We observe in literature that different patients have different conditions, silent symptoms, and additional factors as age or sex that really affects the treatment that will get the result or the same profiling of the disease. So to make this, we work with a data set that has age, sex, chest pain that come from a patient from the Cleveland Hospital, but with this data set has some particularity and is that all were numerical. So we're going to have some mixed data. So we transform the data, age, we create age range to the age. We transform the binary data for sex 1 or 0 to male or female, and the same with chest pain, cholesterol, rest ECG, exercise-induced angina, to differentiate this variable. This allows us to what? To determine, for example, that normal blood pressure was 32% of the results. And some important issue here is that even some people with chest pain, with no chest pain, it's the value 0, are categorized as a heart disease, that has a heart disease. In the next slide, my partner is going to show you how we target or we create this relationship between these variables.
We use Gephi to graph our network and calculate the measures used in the analysis. This is the network we built. Each node represents one characteristic or symptom present in the patients at the Cleveland Hospital, and we created a link between two of them if both are present in at least one person at the same time and that person is actually diagnosed with a heart disease. We use both local and global measures to identify the most important condition and their relationships in the patients. Globally, we calculated the density of the network with a value of 0.768, meaning that the network is quite connected, which from the get-go tells us that a lot of the conditions in the patients do coexist. We also calculated the average clustering coefficient and degree with values of 0.841 and 25.35 respectively, which tell us that the network has tightly linked groups of nodes. The degree distribution shows that the minimum degree of a node is 9, and a larger number of nodes have connections with 25, 30, and 32 other nodes, which further shows the overlapping of characteristics in patients. We calculated both the clustering coefficient and the degree locally, and we can see that most nodes have high clustering coefficient. However, male, high serum cholesterol, and FPS lower than 120 are the nodes with the higher degree and some of the lower clustering coefficients, which could mean that they are hubs in the network, probably because there are some of the most common characteristics in patients, and thus they have more overlaps. When creating the network, edges were assigned a weight that corresponds to the number of times that pair of conditions appear together in a single patient in the original data. In other words, we can know which pairings are most common by looking into the edges with the highest weight. We can see that the three edges with the highest weight are all combinations of those three mentioned nodes, like male and a bit lower than 120, meaning that the combination of these characteristics are the most common in the dataset, with 70% of the patients actually present them at the same time. Finally, we use the Gephi's community detection with a resolution of zero point 0.9 and using the weight of the degrees as a factor to predict groups of nodes highly related together. Here we can see a layout of four different communities found by Gephi separated by color. The four communities have some common relation between illnesses, specifically around the resting blood pressure variable, with almost no overlapping results in the symptoms category. Also, we analyzed each community and we observed that the blue one has a lower risk factors categories results than those in the purple or green communities that are in medical terms more critical conditions. So we can conclude that the conditions, symptoms, and characteristics of the data are highly connected, meaning that there is a lot of overlap between them in multiple patients. Some conditions behave more like hubs than others, which are also the same nodes whose edges to one another are the ones with higher weight in the network, representing that these combinations of characteristics are the most common. And finally, we can see a pattern in the communities calculated that seems to be related to the resting blood pressure variable and could be linked to the severity of the heart condition of the patients. Thank you.
Okay, good, good. And Professor, got any comments?
Okay.
Chief, good.
A very important project. Network science has a lot to do now with medicine, with patients. Uh, it is very interesting the analysis you made. You discover four communities, and then you enter in each community to find why Gephi group in that way the communities, and you discover that there were commonalities in diseases. Okay, very it's very interesting to know that the network is not very big, and it's a very appropriate network to apply community detection, and I guess it's very interesting. I have one or two questions. The average, I guess that the average degree of the network, there's a mistake, I guess, because 25 is very high. I guess it could be 2.5.
No, it's 25. It's not normalized. Is the average degree of each node divided by the number of
Ah,
nodes?
no, excuse me. I was thinking in average path length. Excuse me.
No,
It's
no,
correct.
it's
Okay,
degrees.
sorry. Okay, no, I was thinking in the average path length. Uh, why did you choose this? There are more global measures and more local measures. I want to know why you choose these measures in particular for your
Okay.
project and not other measures.
Well, we went through the different measures we have seen in class, and we tried to think if they would actually give us important information. And some of the measures are related to networks of communication mainly. For example, between the centrality is to see how the communication goes through the network. And this network is not exactly about communication, but links between consecutive nodes. So we decided to choose these measures that are more in terms of the importance and the connections of node to node and not overall dissemination or that kind of analysis, which is not really what this network is about because there's not information passing from one node to another. So we didn't use those measurements.
Okay. Okay, I have no more comments. I don't know if
I have a couple of questions.
Yes.
The first one, you mentioned something about some data transformation, the variable, you transform the variables from, can you explain that? Because I got a little bit lost about transforming some numerical variables into some, I was just looking for the slide, but I cannot find it
It's
now.
that one. It's there.
Yeah, is that one? Is that and the previous one? What happened here? Uh, the original data set was mainly numeric. Age
Okay,
where the age, sex was 0, 1, chest pain 1, 2, 3, 4, uh, uh, press BPS were a number between 188 and 800, 540. Uh, exam exercise induced angina was 0 or 1. So if we work with this original data set, we're going to have some mixed values because sex and exercise induced angina were going to be the same value.
okay,
So
so,
we
okay,
give them
move on. Sorry, so continue, please. Sorry for disturbing you.
okay. So we make them string variables. One was in the sex was transferred to male. Slope was changed to up sloping if it was 1, 2 flat, or down sloping if it was 3. So we, in this case, eliminate any kind of mix of these variables when if it does going don't that doesn't going to work with for us in the network analysis. So
Okay,
we make this change.
okay, got it. And I have another question at the end. Yeah, because you mentioned something just now in the explanation about like this would be considered like a communication network, though this is sort of different. But for example, the concept of a hub here, what would it be? You know, in the case of these diseases and the variables that affect have to do with
Uh,
disease, what would be the meaning of a hub in
okay.
this context for this particular network?
Well, what we saw is that since we're comparing the overlapping of these conditions in patients, that these nodes that we consider hopes are like the most common characteristics in patients and are the characteristics that appear together with others more commonly. That's why we see that their edges are the heaviest because they repeat themselves in combination with the other characteristics. So maybe they are more common or more defining in terms of these diseases and are key characteristics to look in a person when trying to diagnose or something like that. We assume that's our analysis from the data set at least.
Yeah, and I think maybe yeah, I would like to comment on the Professor's question on his questions because not necessarily of the metrics, the measures that we have introduced in class or some of the analysis will apply, or it varies, from from a context to a different one. For example, in one of those variables, for example, the one that you found there, like just just to name one, sorry, I'm looking for example, the average degree. Well, why would
Yes,
be of interest in this particular case? Why would
yes.
be even interesting in
Uh,
the context of the diseases, for the average degree, for example.
yes. So, well, the degree in this network, since each node or each edge is an overlapping or a coincidence in two characteristics, meaning having a high average degree means that all of the conditions, different characteristics we have, are usually paired, and it is common to have pairings of these conditions in patients. So the higher the number, the more connected and at the more at the same time these characteristics present in patients, and the lower they are, the fewer connections or crosses we have with these characteristics. So that was like the idea of.
Good.
that
I
measure.
think it's an interesting progress, and especially that also the communities, like the community identification there is interesting in this particular context of the pages and the diseases. Very good. I think we can move on to the previous well, to the next team. Team number 8. Are you guys ready? Team 8.
Yes, here we are.
Okay. So here we have your video. Transmitting.
Hello everyone, we're Stephanie, Freddy, Jorge, and me, Manuel, and today we're excited to present to you the preliminary results of our project on Bogota's public transportation network. As this is our first partial delivery, we'll be sharing our initial findings and insights into the network's dynamics.
First, a reminder of our main goal: analyze the efficiency and detect different problems within Bogota's public transportation network, with a specific focus on the Transmilenio system. This first partial delivery will be sharing our preliminary finding based on the modeling of transportation distribution through feeding information. This initial phase of the project will be provide a foundational understanding of the network structure and efficiency, serving as a basis for further analysis and optimization efforts in subsequent delivery.
To achieve our objectives and as we present our proposal, we have access to two datasets sourced from Datos Abiertos Bogotá. The first one with entries and the second one with trunk line exits. The data was prepared from Datos Abiertos Bogotá, consolidating daily datasets from January and February of the present year. Our initial exploratory analysis revealed significant trends in user flow across different zones and stations, providing valuable insights into the network's dynamics. For instance, we observed that certain zones, such as Caracas Sur, Auto Norte, Carrera Décima, and Avenida Américas, experience higher user flow, while others, like Eje Ambiental and Ciudad Bolívar, have lower flow. We also were able to identify a really great consistency of data, not only in terms of daily access distribution, but consistency with the peak hours of the Transmilenio system.
Now, let's discuss our proposed network science approach. By utilizing the Python NetworkX library, we generated a bipartite graph representing connections between station and user profiles in the Transmilenio system. By aggregating connections based on Tuyabe card data, we weighted the edge to reflect the strength of each connection in the network. Finally, we iteratively visualized the bipartite graph, tracking the evolution of connections between stations and user profiles over time. Our visualization of the bipartite graph provides a clear understanding of the distribution of stations and the relationship to different types of users in the system.
Based on the bipartite graph, we conducted a thorough analysis of its structure to gather insights into the operation of Transmilenio system, and by the use of centrality measures, we characterized the findings of user profiles and corridors within the network. Our analysis conducted on each graph generated at 30-minute intervals revealed interesting findings. For user profiles, closeness and degree remain consistently for high across the selected timeframe, except for the estudiantil user group, which exhibit lower values, what could be attributed to the low amount of results for this type of users. However, betweenness was uniformly low for all profiles, while density and clustering were consistently high. Similarly, when analyzing centrality measures for corridors, we observed that the values did not vary significantly between different corridors. This suggests that the disposition of stations within the system may contribute to the uniformity of centrality measures across corridors.
Our analysis highlights the high density and connectivity of the Transmilenio network, facilitating passenger flow. The equal distribution of connections between station and user profiles provides redundancy, offering passengers multiple travel options. Further implementation of station node flows is needed for a comprehensive understanding of the network. Performing a one-mode projection is impractical due to the inherent information loss from grouping nodes by Tuyabe car information. Our analysis underscored the importance of network science analysis in providing insights into complex systems like Transmilenio.
Looking ahead, there are key areas for the missing future, such as implementing data cleaning to address atypical data points outside Transmilenio schedule, aggregating output data to accurately determine station occupancy, developing filters to analyze specific behaviors within the network, and a possible exploration of modularity analysis and community analysis to identify usage patterns among different user groups.
Thank you for your attention. This was our preliminary finding on Bogota's public transportation network. If you have any questions or would like further information, please don't hesitate to reach out to us. Thank you for watching.
Okay, clapping. Thank you, Professor. And by the way, after this, I think we should. One question that we missed in the last team was to ask them what would be the next step. What they want to accomplish at the end of the term. The next steps. I think that was missing in the previous presentation. Professor.
Okay. I guess this group have the data, have analyzed very well the data. I guess it's a big project. I recommend if we can go to the last slide.
About the next steps.
Yes, I don't know if these 4 steps are big steps. Develop the filters in exploration of modularity and community analysis. I suggest that this last step is very important, according with what we have seen in the course and with the importance of finding clusters or communities. I don't know if you could do all 4 steps. I don't know if there's time, but I guess I don't know if you could think if these 4 steps are too much, or you could do less steps. One big question that I have is, in your goal you said that you were going to analyze efficiency, and I don't see clearly where is the efficiency in the slides. Efficiency of what type? Because you have a bipartite graph, you have the stations, you have the type of users, and in what sense are you analyzing the efficiency of what? Of the stations, of the persons?
Yeah,
For me, it is not clear, but
yeah,
maybe for you you have this clear. So
yeah. Probably here in the presentation we didn't put it explicitly. That was a mistake from ours side. But the idea is to, because we put that in the paper, is to see the efficiency in terms of like feed in and feed out of the stations. So we can find, for example, stations that are being poorly utilized, or for example, lines that are not matching the expectations in certain hour range. So we can identify like this efficiency in terms of providing the users access to the stations. So in this first implementation that we did, we only considered the feeding information. We haven't placed the feed out just yet. So that is why we don't have like a clear like insight about the actual efficiency, because we are not measuring the occupancy just now. The idea is the efficiency in terms of feed in, feed out based on the occupancy of the stations. So since we are not considering just yet the exits of each one of the stations, we are not there yet. But that is one of the steps that we are aiming to deliver in the next delivery.
But regarding the efficiency, how do you plan to measure? You mentioned like some, in general terms, like the use of the stations and this kind of information. But have you thought of some metrics or measures to measure this type of efficiency?
Well, initially we are only considering like the main centrality measures because that way we can identify like a typical nodes, for example. Because in terms of the transportation system, the trend is that the in the peak hours all of the stations have like the same centrality, for example, because it's the time where everyone goes out, for example. So in terms of in the occupancy, we could see water stations, for example, are not being disoccupied at the same time that the other stations. So that way we could measure, for example, these three stations were empty before this other three, so it has better efficiency in terms of feeding buses to the users, for example. So that is why with the feed in and feed out and the centrality measures, we could see these type of behaviors, or that is our expectation at least.
Okay, but I guess you must have a baseline. You have to know from data, from historical data, or I don't know where when a station is efficient in terms of the people that are entering and are going out. You have to have a baseline, 100, 200, and 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 with that in mind, you could say it's efficient or it's not. What criterion do you have to, for example, when is a station efficient? When what is the definition of efficient or the criterion to know when a station is or not efficient? Is my question.
No, okay, well, for how I see it, I don't know if my teammates have another opinion, but that is really tricky to say, and especially with these transportation issues, because it is a big problem with a lot of variables. But what we are going to try to do is set this baseline based on the means, on the average values that we get from all the lines in certain type of days. What we want to do is like segregate, for example, on Monday, this is the mean. What is under that mean, it will be not efficient. Or this is Friday, this is the average for Friday. What is under that line is not going to be efficient, because it is really difficult to have like that base value, because it's not the same as well taking a Friday from, for example, January, that taking a Friday from May, because in January there is vacations. There are a lot of students that are not using the
Yes.
transportation system. So that is why we
So I
don't
guess,
take that baseline
okay.
like from the historical data, but from the data that we are measuring in terms of the average.
So I guess you have to have an efficiency each day of the week.
Could you repeat that?
Friday, Thursday. Could be that because the behavior of it is very different in Sunday, for example, or on Friday. So you could have a baseline for each day.
Yeah,
You
yeah,
could
that could
choose
be.
one or two, or you could choose to analyze 1 or 2 days.
Yeah, it could be, but yeah, that is why we and
Okay,
even in our variables that we set there, we set that day of the week, so we could have like that segregation by day and have that baseline by day. But we don't have like that like completely defined just yet. But we have like the means to get to there if
okay,
it's following this path.
okay.
I was wondering whether, because well, the figures, are very useful to understand some of the trends, but like when you show these tables, like when how this could be shown in a more graphical way and tell you something about the particular um, bus stations, because you see all those numbers now, and when you analyze these numbers, what did you observe regarding these tables and the particular bus stations? What could you summarize about this table? Because when you look at the numbers, they look very similar. So what can you tell regarding these tables and the
This information is about the user profile. In the majority of the work done was about user profile and how the different user profiles related to the stations. The greater impact it's about the how different users profiles are distributed along the translinear network, and it's if it's a specific profile that has I don't know, lack of accessibility due to the spars of the stations, we can identify in this with this data.
Okay.
Yeah, and if I may add,
Yeah.
if you stay there just a bit, teacher, as you can see, as you said, is really similar, but because these two specific tables are showing like the average for the user profile, as Freddy is saying. So the thing is that since we are averaging every day of the week and at every hour, the trend it goes up because the closeness, like in the majority of the day, is going to be high because all the users are entering like really sparse in all the nodes, and that is something that we can see in the GIF that we place there. As you can see, all the stations are like grown at the same time. So that is why it is like really similar measurements. So that is where we need to start like segregating by the filters that we haven't added just yet. But we can identify, for example, with the student group that is really really low, but because this is January, so they are not studying, and for the discapacity, the unable people, the discapacidad one, as you can see, is a really a bit small than the other one, but because and that is unexpected behavior, let's say, because those people are not moving as much as the rest of the people, for example.
And we can see in this data also the low betweenness. In a lot big difference between closeness degree and betweenness. This closeness degree density has high values and low betweenness high low values. We think this is for we don't put the data of the I don't know how to say.
Okay, I guess it's interesting because normally closeness and betweenness are very similar. And
No,
finding networks that where betweenness and closeness are very different is not easy.
Yeah, I think the thing here is because we don't have like the information about the
Yes.
trajectory of the users. We don't know what are like, for example, in between stations or bridge stations. So that is why we don't see like these central steps of that will determine the betweenness. And also since we haven't added just yet the exits and we don't
it's
have the actual occupancy of each station, probably when we add that, the betweenness is going to be different because we're going to see stations that have a bigger occupancy. So that bigger occupancy may explain a better betweenness, because if a station has much more users at the same time that other stations, it may suggest that those stations are being used to move to another bus or some things like that. So we need to add that exit information in order to
Okay.
determine that.
Okay.
Okay.
Okay. Very good.
If I were doing this project, guys, if I were doing this project, I would concentrate in the students. Okay. Eh, Anónimos, adulto mayor, estudiantes, discapacidad. It would be very interesting. I, it's a crazy idea, but if you concentrate in students, you could get results that could be of use to all of us. How 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 is how is the behavior of students in Transmilenio? How many students are when the students are more common to be in the Transmilenio? But okay, it's a crazy idea.
Okay. Very, very good. Very good. Very nice projecting the
Thanks so
analysis.
much.
Very, very well. Thank you. So let's move on to team number 2. Are you guys there? Team 2.
Everyone.
Yes, teacher.
Today, my team, Sergio, Santiago, and Hello, everyone. Today, my team, Sergio, Santiago, and Laura, are going to show you the measures and findings of our network analysis. Our project object is to develop a mathematical roadmap based on a knowledge graph for which it is necessary to perform a detailed analysis of the network to identify patterns and connection between mathematical concepts.
So let's talk about the dataset. And our initial dataset was a knowledge graph consisting of four interconnected networks with a similar structure. To move forward with the project, we strategically select a proof wiki network based on its significance, diversity, and size. After cleaning, the network contained approximately uh, 14,000 theorems nodes, 10,000 definition nodes, and 1,000 nodes belonging to other categories. And for data handling, the primary analysis used the clean proof wiki dataset. The cleaning process involved removing isolated nodes and replacing missing values with empty lists. In addition, we construct subgraphs from the proof wiki network representing specific areas of mathematics. To extract its subgraph, we eliminate nodes from other categories. However, we preserve a connection by maintaining relationship inheritance with neighboring nodes.
Some network methods applied include global measures, centrally measures, and community detection. The related results are shown below.
Well, here in the page of results, these are the principal centrality measures for network proof wiki. Here you watch closeness centrality distribution, between the centrality distribution, and agent centrality distribution. And our principal measure is agent vector centrality because the importance and influence in the network of for every node is better determined by this measure. In the next case, this is the principal graph by agent vector centrality. This colorated by our three types of data and theorems in blue, others in green color, and definitions in orange color. In this case, it's very remarkable and the importance of the definitions for our knowledge network. So in this page, we are watching the principal component of our Prof Wiki graph. Almost 99% of the graph is in here. Here we have two networks, explicitly area on calculus and in the right side geometry. And this is a filtering graph. It's in calculus and geometry. And here the remarkable is we calculate the communities, modularity classes of these communities. And it's very high, the modularity for the community. So that means the communities are very distinguishable in our network. So again, the principal nodes are definitions. In the next slide here, we can see who is this important nodes in calculus and geometry. For example, definitions like a set, element, mapping, subset, real number, real function, topological space, integer, and others are very important in calculus. But in geometry, definition set, element, mapping, subset, real number is very important. Point, appear null, integer number, object, sequence, line, straight line. And so this is very important for us because in this filtered network, we can find the principal concepts for every particular area of mathematics. Thank you so much.
Okay, interesting. Let me just go back to the network where it's the first shot of the network. So is this your network, the one on the background? Or not?
Yes, teacher.
That's the first time it appears. But let me just go to maybe move forward a little bit to have it there handy, Yeah, because we never saw it, and then we just went to the analysis. I think we missed out, and but later on it appeared somehow. This one, Professor.
Okay, I guess these networks are too dense for analysis. When you see a network like that, it's like a hairball. And how many, for example, this how many nodes?
Yeah.
13,000 nodes?
How many nodes based on these values here?
Okay.
Is the sum of that
Sorry,
the sum is
30, 20,
Okay.
25,
Like, oh,
25,000.
25,000. Yes,
okay.
25,000 nodes.
I guess you have, I don't know, but you have to reduce the size because
But
when you
they
find,
already, Professor, they already did, right? Because the original data set was 47,000, and they took 25,000, right? Right,
okay,
guys?
but it's too,
Yes.
I
Yes.
guess it's too big. I don't know. Uh,
Santiago, what is
what is the goal of the project?
The
Santiago?
goal is building a roadmap generator of in the on the particular area of the mathematics. So, taking the advice of our teacher, maybe we can reduce our goal and focus in the calculus, for example, or geometry or algebra,
Okay,
any of them.
I was thinking, it's only an idea, okay? It's only an idea. Uh, in calculus, there are a lot of theorems, but 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 these theorems are used or are not used, are related to other theorems.
Yes, we clean that. The
Okay,
theorems that are not related to another ones or another axioms or definition was cleaned. They are not in the in the net.
they are not.
No, they are not. The isolate nodes in all categories and in the main graph, they are not inside.
What do you
Okay,
mean? What do you mean you're not
uh,
inside?
let let
I
me
mean, there is only nodes that are related to another nodes.
okay. The nodes are definitions and theorems. The nodes.
Definitions, theorems, or others. That others is a category that is inside
Action.
colorarium and actions.
Corollary. Okay,
Yeah, yeah. Axioms, examples, little proofs, little tables of tangent function, these kind of things.
Uh, uh, and what are the edges? What is the relation between two nodes?
Is a reference. Is the
If I
theorem
use
or
a theorem
axiom is
for
needed.
proving another theorem, there is a link, something like that.
Uh,
they're somehow related, right?
Okay.
Right? That
what?
that the two concepts, or the information that each node represents, when they are connected, is that there is as you mentioned, a reference or some relation between the two concepts, right?
Yes, yes, they are related, because another theorems are needed to make another theorem, or there is an action that is based on the theorems, something like that. Because this network was in the paper was intent to use for a machine learning model to reproduce more theorems and axioms.
Okay. Farid has a comment. Farid
Okay.
has a comment or question. Farid, Farid, you raise your hand, right? Or was it by mistake? Farid, are you there? I guess not. Okay. Just to clarify, you say a roadmap. So in the end, how would you expect, or how do you expect to show this roadmap based on the network?
For example, I have learning derivatives or maybe integrals in calculus network, but my only knowledge is about definition of set, definition of a straight line, and this is my start point. And I want to build a path in my network from my start point to my final point derivates or integrals.
Okay, so it's like finding the paths here, like in this network, finding a path that takes me from one concept or from a set of concepts to the goal, right? That
Yeah,
is,
yeah, yeah. So
Right.
the final products maybe one image with this path, or maybe one list with these subjects or topics.
maybe a sub network, right? Like a part of the network, a sub network that takes.
Yeah,
Yes,
yeah, yeah, yeah,
exactly,
yeah.
Juan.
Okay, good, good. Professor, any other?
My question is, this project, for example, I want to know about topology, that it's a mathematical concept. This roadmap generator is going to give me all the topics that I need to be proficient in topology. He's going to tell me study first calculus, then the roadmap is like that. Is for help
No, no.
a person
It's more
who want to know
specific
a
in
concept,
theorems.
or I
It's
am
more
wrong?
no, it's more specific in theorems, definitions and actions. Topology is a subnet of the main graph, so the roadmap will be only in the mathematics topics that like topology, that is a subgraph that we generate. We have topology.
But yeah, yeah. But in this subgraph, you have contained basics definition on mathematics, like a definition of set, definition of element, definition of very basic concepts of mathematics are in every subgraph. So if your start point is very basic, you can learn it, or you can view the path from this point. For example, from definition of set.
Santiago, but also like by showing this type of network, like for example, if it was related to topology, maybe the topology network, then maybe when you highlight these nodes, it tells you what are the most relevant concept or most important concepts that you should focus on to study the whole field, right? Or that you should learn about that
Yeah,
particular.
yeah, 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 yeah. Using agent vector centrality, these nodes are the very important in
These are
influence on
the main data
every graph.
sets in this particular field. Okay, good, nice,
Okay,
interesting.
but one last, for example, between centrality could be very important because it can show you the the topics that link geometry to calculus, for example. That link. So between centrality could be important here because are the bridges, okay? The bridges. And in a knowledge graph, it is important these nodes because are the nodes that link one community to another community. Are the topics that are interdisciplinary. I don't know if it's clear what I have just said.
Yeah, I think you're right. Very well
So,
appreciated.
so, so between us and closeness centrality could be are the theorems that are more related, that have more relations to so 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 the centrality measures, I guess the centrality measures play a very important role here. But I don't know if the study of the centrality measures could be in opposition to the objective you have of the project. I don't know if that
I
roadmap
I,
generator has to do with what I've just said. So I said it
I
because
don't know.
I guess it's important, but maybe this what I have just said
I
not related to your goal. I don't know.
actually I don't know, but if you show me the comparative graph between calculus and geometry again, please, you can see these communities, and
Okay.
these communities has a very representative ideas on mathematics for me. For example, when you analyze the principal communities, you can confirm uh, theorems on similar topics or definition on similar topics are very closer. So if maybe the focus is on analysis, the central measures on nodes, but to the communities on the principal or on the main network,
Yes.
and so analysis these communities is maybe the way. I don't know actually, but very interesting point.
One last observation. Analyzing the communities could be very important because the structure of the community could reveal that, for example, the structure of calculus is different to the structure of geometry. The 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 structure of the communities could be different, so they could guide us to know, okay, the 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 theorems could be very different. The way the historically that were discovered the theorems, I mean, the structure of each topic of mathematics could reveal a lot of things.
Okay. Yeah. Well, one last question. What is
But this, okay.
no? My last question is no. Sorry. If, do you have? Did you need to say something else, Professor? Were you going to say something else?
No, no more, no more, no
Okay.
more.
No. Just what is the next step? What do you want to accomplish at the end regarding this roadmap? Roadmap to identify the roadmap. What are your plans till the end of the term with this project in the class?
Okay, the idea was, for example, I built this roadmap generator on very specific area of the mathematics, and maybe the inputs is one definition, one start point of my network, and I want find the best path to my final point. Maybe a subgraph with this path is or next step. How build this generator
And also, as Professor was suggesting, maybe to focus a little bit more on the community analysis, to see what.
yeah.
Okay.
It's very large
Yeah.
the approaches on this project.
Very nice. Very nice. Very good, guys. So let's move on to team number.
Hello.
Oh, sorry. This is also. Is it okay? This video? Yes. Right.
Yes.
Good teacher.
Team number 4. Okay. Yeah, forgot about that. There was another project about. Farid, do you want to say something? Your hand is still up. You raise your hand. I guess he did it by mistake. But anyways.
Hello. We're gonna post you our project which is the identification of a critical nodes on a transmitter transportation network. So for this, we're gonna be talking about the objectives and the scope, the literature review, the case of study, network dataset, process analysis, and some preliminary results. So first of all, about the objectives and the scope. First of all, we propose three objectives, which are analyze time, demand characteristics of the public transport network in Bogota, identifying critical elements in the public transport network based on open data provided by Transmilenio, and propose a new plan for the current public transportation network in Bogota, focusing on improving its efficiency. The seated, okay, about the literature review. The seated text below not only introduce some metrics for a deeper understanding of transportation networks and the identification of critical nodes,
but also provide value and analysis and data related to public transportation in Bogota, which has a specific focus on Transmilenio. Um, about our case of study is about list research, focusing on critical nodes. Those are significantly impact network performance. These nodes are as bottlenecks and affect traffic flows, accessibility, and overall system resiliency. And the study propose methodology that combines two key measures, which are between centrality and network efficiency.
Now we are going to discuss the dataset. Initially, it was a quite disorganized and extensive Excel file with a structure similar to the one to show on the slide, where we had files like station, time, the date of the month, and the total number of people who enter each station. So now for analyze, we filter and organize it using Python, leave only the data corresponding to the month of February and salve it in a text file with a format of date, station, and number of the people who enter. Then manually we build an Excel file to represent a graph using the station like nodes and the street like links. So when we have that, we exported this graph to Gefty and obtain the visualized result.
In the preliminary results, we use two algorithms in Gephi, between centrality and clustering coefficient. In team, we are looking for the critical nodes of the network, and the right is how it currently looks. Station transmit, you know, and in the future, the idea is complete cross the data set with some statistical graphs, the graph information in the order to find relevant information. Thanks. Station transmit, you know.
Okay. So no conclusion so far. Guys, before we ask some questions like, can you tell us about this analysis? What do you get by looking at the graphs and the but you did not report the centrality measures, did you? Here, at least on the video, guys. You did not report the value.
Again, Prof.
Hello.
Hello, teacher. Again, the question?
Yeah, that you did report on the video the results of the numerical now analysis. You know the values. Oscar and Angela and Pedro.
Okay.
What's the conclusion so far of the analysis? What can you tell us about this by looking at the images? I mean the networks, and also by analyzing these values that you obtained, the between centrality and the clustering coefficient.
Okay. No sé cómo decirlo. In the next report, we attune the statistics because we yet no.
So you didn't, but how did you said you mentioned that as I understand, you said that you don't have the numbers of the statistics yet. Is that what you're saying?
Yes, but we don't attune this report. But we will the manualmente, bueno, the graph because the data set is difficult analyzing because in Python have been difficult. I have problems with analyzing data.
So
Now
you can implement it, but you said you computed those. So you mentioned you. So what you're saying is that you did not compute the centrality measures and the clustering coefficient. You couldn't do it yet.
Y-
The other team members, can you complement the answer? Yeah, I'm looking at your report here, and you just have the images, but you don't have the analysis. So you mentioned that you draw the networks manually, but not like you did not report the statistics, right? Is that what you're saying? You did not report the centrality between the centrality and the crossing coefficient. You haven't computed it yet?
Y- Dame un segundo, qué pena. Um, that algorithms, we use that algorithms in Gefty.
But you don't have the numbers, Angela? You
The
don't know?
numbers?
Yeah,
Um,
the centrality measures this, at least this centrality between the centrality and the clustering coefficient. You don't have them, do you?
no, we use we only use the analysis that we do in Gefty,
Oh,
and we conclude three levels of nodes: the purple, the green, and the orange.
okay, got it. Professor, I think this is, yeah, because they didn't use, so yeah, they didn't use
Yes.
NetworkX to program it, I guess. That's why, Professor. What can you tell regarding the tool that they used?
Okay, I guess that when I see the network at the right with colors, that is in Gephi, okay?
Yes,
Yes.
yes.
Yes, teacher.
I guess that you calculated between the centrality, but if you go to Gephi, there is a how do you say pestaña? There is a tab that said data laboratory, laboratorio de datos. Every time that you color the network, for some reason, the numeric data automatically is calculated by Gephi. So I am sure that what Luis Fernando has asked you is in Gephi when you look at this data laboratory. Uh,
Okay.
okay. If you have any problem with that, you could send me an email, and I could show you how to how to
How to do it?
visualize the the between centrality in Gephi. Uh, could we go to the slide of the goal of the project, please?
Yes, yes. That's what I wanted to focus, like to
Okay.
relate these measures to the project goal.
Okay. One question is why those two measures and not other measures?
Exactly.
Is between the centrality could be important, but there are more measures. Okay, but the last objective is very, very, very broad, very broad.
Yeah, I would say that you rather discard
The
this
new
one,
plan
right?
for the public transport is a work of a group of 10 persons in Transmilenio. I don't know.
Yeah,
Uh,
that's why, Professor Wright, they rather discard this one, remove it,
yes,
and just
I
focus on these two one. Maybe the second one would be interesting.
yes, but I want to make a question because it is important with relation to the other Transmilenio project. I guess that the two Transmilenio projects are focusing very different the problem. So it's very interesting because there are two very different ways. But I want to ask the same question that I asked to the other Transmilenio group. What is efficiency? When you talk about efficiency in the goal of the project, focus on improving its efficiency, okay? Its efficiency in what sense? Because
And maybe that could be answered by looking at the network. If you could just explain what the network is showing.
looking at the network could show us.
Yeah, can you tell us what is the network? I lost it now. Hey, this one. So what are we seeing here? guys?
The initial graph when before analyzing in Gephi.
Yeah, well, what are the nodes and what are the relations between the nodes?
Nodes is
Stations?
stations, yes, and links with streets.
It's the physical network. It's the physical.
The physical network is just the way it's the layout that is.
Yes.
Okay, okay. Yeah, but okay. But again, going back to the professor's question, what is how do you plan to measure the efficiency, and in what sense? Because there are several measures of interest regarding the efficiency. What have you thought about it, guys? Are you there? Did you understand the question?
No.
Yeah, but in this moment, in this first part of the project, we are concentrate in search the critical points for improve the improve the ¿cómo se dice en inglés? Improve the
Tell me,
rutas.
what is a critical point? In what sense?
Exactly.
Critical point is a point that could be the station could be broken, or a critical point is when there are too much people, or a
Yeah, yeah, the last.
The demand is too high, right?
Yeah,
But
that
you
is
have
a
to have a
point
baseline.
for us.
Like the other project, you have to have a baseline. You have to define what is a crowded station, 100 persons, 200, and establish a baseline, because to know when a node is critical, you have to establish a baseline, because if you don't establish the baseline, you could not know what is critical and what is not critical. So this is important.
Yeah, and I guess you missed, the analysis, and I can see, in the video we missed that, and also in the report I can tell that you just show the images, but you don't explain them, and you don't analyze them. And it's because if you don't have the numbers either, to, as professor said, they may be there, but you weren't able to see them, to take them from the software, the report of these measures, because and again, I think it's important to focus on the particular what you want to accomplish, and if these are the appropriate measures, why these two and not others that professor asked. Got any ideas or any answer why you picked these two? How are they are related to how the system works, or the efficiency, or the to identify the critical points, guys? Hello.
We want reconstruct the network of the Transmilenio. So, o sea, we need the critical points for now. What are the stations that the people's more use, and what are the stations that the people less use, and with that we can do other time the network the Transmilenio, for that of for that with that will be more efficient.
Yeah, but then you say that by for example, by computing the between the centrality, you can identify those critical points regarding the demand. Angela, that can help.
You can repeat, please. I don't understand.
Typical professor, as you said that, and we agree that you want to identify the critical points, the critical stations, like the ones that have maybe more higher demand, or that are more crowded, but then why by computing between the centrality, you can do that, or that will help you identify those critical stations. And as Professor asked, why these measures as opposed to other ones? Hello? You have the mathematical definitions, but then you need to see, by understanding the definitions in each particular problem, you need to see whether they are appropriate or not. For example, in this case, regarding the demand of the users in a particular station. I guess you need to study that, right, Professor? Like focus on that. What are the appropriate measures for what they want to accomplish, to answer those questions.
Yes, for example, degree centrality could be more appropriate than betweenness. I don't know, but it's you have to be clear what is efficiency and what you're trying to achieve. We don't expect the plan. We don't expect a plan for suggesting changes in Transmilenio because this is very, very broad. But it's important that your goals are concrete and you know exactly what is efficiency and then you could know what tools you use. Communities, for example, could be important, but if you must first define what are you trying to accomplish, and then you could know I need communities, I need centralities, I need the density, I need to know global measures or local measures. So it is important that you rethink a little bit the goals, and in that base it's going to be clear, I guess, what tools are you going to use for getting to the goal. Okay.
Yes, why Gephi and not like going to Network X? Because I think you need to still to perform. You need to push the accelerators. For the rest of the report, because I think it's still poor. The progress on this project. Guys, why did you pick Gephi? As a first tool, it's used for writing and that, right, Professor? But for further analysis, maybe you need a better way to do it. And you guys are programmers, some of you.
Yes. I think that almost all groups began with Gephi, but this is an important point that Luis Fernando mentioned. In these preliminary results of the project, Gephi is very good, but if you want to achieve the goal, I think I'm not sure, but I think that in some moment you have to use NetworkX because NetworkX is more appropriate for big networks for calculating the statistics. So I guess.
Yeah, you need to work harder. As a push. You need a push to work and accomplish. At least some of the goals that you proposed. Okay, let's move on to team. I guess this is team number 3. Can you confirm this is team number 3, right?
Yes, Professor.
Yes, teacher.
Okay.
Hi everyone, today we're going to present analysis of flavor networks in Latin America cuisine, a comparative study of regional flavor combinations. It is presented by Sergio Manuel Arguello, Sebastián Campiño, and me, Valentina Ruiz. Our goal is to examine through network science theory the flavor combinations present in the traditional or regional cuisine of Latin American countries. And the scope of the project is to analyze flavor combinations to draw conclusions about American cuisines and explore how they impact the nutrient intake, potentially identifying dietary interventions from improving population health. Talking about our network data set, is a network of culinary ingredients and their shared flavor compounds. In here include in the notes the ingredients and in the agents the presence of flavor compounds shared among the ingredients. There are 2 topologies. The first one is a network of ingredients related by the associated flavor contouring chemical components. And the second one is identifying the origin of different recipes from the region based on the flavor profiles. Okay, talking about the proposed network, first of all, an exploratory analysis of the ingredient networks provided by the paper server is conducted. So the first data set relates pairs of ingredients and the frequency with which they appear in the recipes of preparations. This is shown in the figure that we can see here in the left. The distribution of this dataset is observed, revealing there are ingredients that only combine in few dishes, and there are few ingredients that appear repeatedly in many preparations. As we can see here, this is the distribution of the number of dishes based on the number of common ingredients. Here in the right, we can see histogram of dish distribution by cuisine type. That is the data set that is presented to us, and we can see here that in North America is the one that the most preparations are in. Then we can see here the histogram of the top of the 10 most common ingredients across all present recipes. In here in the first, we have egg, then we have wheat, and then we have butter, and continuing with the top 10. Now in here, we have three important networks, and this is about the first dataset that we found. It's a histogram of the degree distribution in the ingredient network. So then we can find here like the visualization of the ingredient network with the node size based on degree and ingredient label corresponding to the node, where links between nodes have weights with darker links indicating higher weight. In here we have like a lot of nodes, so it is many difficult to see that, but the color, it is like in most dark, indicate the higher weight. Here we have 226 nodes, and then we have the exploratory analysis of the network of ingredients associated with each type of cuisine. First, we have the histogram of the weight distribution for the network of different types of cuisine in different geographical areas. Here we aren't like specific in Latin America still. We are seeing in different geographical areas. And here is the visualization of the ingredient network. Then we have the analysis. So in here we can see a histogram of the 15 most common ingredients in Latin America. It is the other network that we want to focus, that it is just in Latin America. And here is an histogram of great distribution, but in Latin America. Talking about the results, we obtained that network dataset and the visualization of Latin America subnetwork graph, applying the clustering algorithm, which associates by means of the proximity of ingredients between dishes, and the node size is related to the degree. Here we have central measures and global measures. Our conclusions is that we need to reconstruct the data from the files provided by the author in order to conduct a better analysis of what is consumed in Latin America regarding the variety of ingredients and nutritional content. The networks exhibit a behavior similar through not strictly to a small word network due to their high clustering coefficient. Thank you.
Okay. Let me see, Professor. Let me see.
Okay.
Uh-huh.
There is. I have.
Hi, everyone.
No,
okay.
Go ahead. I was just one browsing.
I have a question to Sebastian and Valentina. What is a dish? How I mean, the network, the nodes are ingredients, and the edges are
Uh, Professor, we have two datasets. The first one has like the first column is an ingredient, the second column is another ingredient, so it's a couple of ingredients, and the third column is like the frequency of those ingredients are in some recipes. And the second dataset, we have first in the first column, we have the type of cuisine, like geographically. I mean, for example, Latin American, we are focusing in that cuisine. Or for example, I don't know, North America are the ingredients of that. I mean, every row is a recipe in that data set. So each column is an ingredient of that recipe. And the first column is like the part or the type of cuisine. So yeah, but basically is that.
Sebastian, these are the two topologies that you are talking about, right? The one,
Yes,
the first network of ingredients, and how they're related by the particular flavors. Sorry.
yes. For example, in that part in with the histograms, you can see like in more forward a
No,
little
but
bit like.
can you, so is this are these the two networks?
No, no. For example, in that one, in like in the right, is not the network from us, like the network uh, we, co- we, sorry, we.
Have a particular network, but it's a similar type of network to which topology? The first one, this one on the right?
Actually, that network has another like elements, like the
Yeah,
compounds
but it's similar
of.
to you, right? Because they don't have the ingredients, right,
Yes,
Sebastian?
like in the left part, this we have
We're
to we have to analyze that network, but at this moment we didn't yet.
okay.
So basically, the next step is do a relationship between the ingredient and the chemical compounds for see how healthy or nutritive are like the recipes in Latin America, basically.
Yes, I want to complete that answer. In the graphic, the last graphic, the topology with the right is the previously network to construct the first network. That is a previously work of the authors.
But wait. So this is similar to yours, right? Because you have the ingredients.
Yes, that is a initial bipartite network, and in the left column there are the ingredients, and the right column the chemical components associated with flavor. Then with these principles, they construct the first topology, make it the edges the ingredients, and the links are the shared chemical components.
Okay.
Then this network is before at the first topology. With this network, they construct the first topology.
Okay. And that, let me see. But what about the second one? Because the one is it says the origin of different recipes from a region. So they are associated to a particular region, sorry, based on the flavor profiles, right?
Yes.
And because this analysis is here, are these two analyses based for each particular, I mean, performed on each particular network? So this is for the second one,
Yes.
for the second
Yes,
one, and this
first
one
one
for,
and second one, right?
sorry, this is for the first one, and this one for the second one.
Yes.
Is
For
that
example, in the right hand, you can see cuisine, or for example, the first the most Like in the data set, almost most of the data is from North America because the people that was working, no, the web page where they obtain the data is like an American web page. So almost all the recipes are from there. But yeah, like basically we worked with both of those networks.
But this analysis is only for the first network, right? Because it's based on the ingredients. Is that true? So for the first, this analysis, these two graphs are for the first network. These two figures.
Yes, and in the document, the labeling of the graphs have it's more complete that with this title we can't identify it, but every graph is for different topology because the authors work with two topologies, and our project we divide the second topology just focus in Latin America.
Okay.
Then some of these graphics, okay, the graphics are mixed and the titles don't specify, but the graphics are of every topology.
Yeah, because I think that's what made this confusing, right, Professor, and everyone, because
Yes.
you performed the analysis on both networks at the same time. You know, like
Yes.
they're intertwined there. You know, like mixed. So like this is what
Yes.
first network, then this one is I guess also, but then this one is for the other network, and this one is also for the
Yes.
first network, and this one is for the other network, and this one is for the types of cuisine, right?
No, this is a new network. This is just focusing in Latin America.
Yeah,
That one.
but it's about the ingredients. I mean, which one of the two topologies is this one? The second one?
The second.
The second one because the second network has the origin of the cuisine, so we needed to use the second network for extract, uh, like filter
Ingredients.
the recipes.
The information about the ingredients in the recipes. Professor, in comments, I think that's what maybe is confused. Maybe you should separate the two analyses for the two types of networks. Professor?
Yes, I think that you have to concentrate in this network that we are seeing now, that is the Latin America subnetwork. Because I guess the goal of your project is to analyze the Latin American ditches. It's correct?
Yes, you're right. Actually, maybe in the
I think
like
that
in the
what you have
GitHub.
to do is try to construct one network. I don't know if construct one network with Latin American ingredients and a network where you could extract from the network the nutritional information, because the nutritional information is what you want to investigate.
Yeah, I wanted to ask you guys, how did you perform this clustering analysis? But what algorithms did you use to cluster this network? To find the clusters, rather.
Yes. Sorry, I don't remember. Like Levin, something like that. I don't remember.
Okay, that should be specified. By the way, you guys are making us hungry, right? By showing these pictures. But anyways, um, yeah, I think maybe focusing as Professor said, but you already found something, right, regarding the. I mean, after clustering, did you get to the point of going deep into the identify the ingredients, the main ingredients, and that from the network? Do you already do that, or that's something you need to do for the next report?
Like we found like the most common ingredients in like Latin American cuisine. So we will those ingredients for like do a relationship with the chemical compounds and see the nutritional value. but that's the next step.
Okay, can you explain this second conclusion? Why do you say this?
Okay, basically, we have like when we see the measures, like global and central measures, we found that we have a high value of clustering coefficient because we have hubs. We have like small longest path. So like those are properties of a small world network. Also, we don't have a normal distribution, so it's more or less like a small world network. Not at all, but has like some characteristics.
Okay, Professor, do you have anything else to ask or to say?
No, no, no.
Very good, very good, very nice. I don't know if we maybe, well, we need to maybe rush a little bit. I would suggest maybe 5 minutes, 5 minute break, so we can like, but I don't know if we can have time. Yeah, let's do it. The 10-minute break, and then we need to make sure that we finish this presentation today. But very nice, nice job.
Okay.
Yeah, nice, nice. Okay, so it's 7:37. So 7:47. We'll be back. Okay, and we'll continue with this presentation.
Okay.
Okay. See you guys in a few. Okay, okay, we can continue, right? Oh, okay, yes, yes, Sebastian. Okay, good, yeah. It's giving us the information regarding the clustering algorithm, right?
Hi, teacher. Sorry, I think that we sent the video of the previous task. Let me send you the updated, yeah, the one for the most recent one.
Sorry, I'm lost. I didn't understand. What's
The
the team number?
team number 6, the one that
6.
you are going to play.
So you're saying that this one that I'm showing is not updated?
The thing is that it seems like we sent the video from the previous task and not the one that we record yesterday. Let me send you the one.
An update, right?
And the thing is, this is the one that we are seeing here is the video for the previous task, not for the today's task.
Oh, I see. So you didn't you mention the older one.
The mini project.
Yeah, yeah.
But this is the one I'm lost now. Sorry.
Yeah, this is the one that is in the document. I just checked it. I'm not sure why we added that one.
Oh, so you put the wrong. Let me see. I'm lost now. Sorry. Let me see.
Wrong video in the correct. Yeah, in the document for today's task.
I'm lost. So is this the right one? The one I'm just copying pasting your link because we need to move on because we're still missing 4 things. This is the one. This
is not the one for today's task.
So is this correct? The one I'm seeing there?
No, that is the video from the previous task. Let me send you the one for the today's task, please.
But that's the one I just copy pasted from your.
Yeah. There was on our side. We pasted the wrong link.
But did you just share one there on the chat? Okay, let's move on to the another thing because we're wasting time. Just update that.
Yeah, Paula had just sent the.
I'm going to a different one.
Yeah, Paula just sent the one from.
This is the right lane. Teacher.
I just need to move on, so I'm gonna move to number 5 where we fix this because we are here to stay too long and we need to. So we'll move on to team number 5. Okay, so start.
Our results so far in developing our project. Recall this project is about drawing concurrence networks from a Colombian newspapers.
Sorry. I think I don't know if I'll just rewind.
Our results so far in developing our project. Recall this project is about drawing concurrence networks from a Colombian newspapers articles and opinion pieces as to illustrate the newspaper's biases and archetypes in narrative depiction. We changed the source from El Espectador to El Tiempo due to access issues, but all the rest is still the same. And the literature review in this subject matter chose a descriptive approach so that authors have focused in counting the number of times a word occurs and in inferring the occurrence of words from prior words. We will not do any of this. Instead, we'll focus in concurrence networks, which are networks depictive of connection between concepts, not words, but concepts, and depictive of communities of concepts, which are derivatives from the strength of the connections, of the interconnectedness of concepts. So you'll speak of communities where concepts are strongly connected. As you know, our case study is based on The Witcher, but I will not stop there because we have very little time. You can take the raw data, the articles, and split them into tables like that, category, title, etc. What we did this time was we took the article's contents and split them into paragraphs so that we look into every paragraph for co-occurrence of concepts, paragraph by paragraph. Now, I have to recall for this time, for this occasion, we have not used as many articles as we will for final submission of the project, but only 3. In fact, 2 news articles and 1 opinion piece. Recall the purpose of this presentation is to show you what we are going to do and what we are doing already, but not the final result, so that's fine. Now, the process is as follows. You take the raw text and you get rid of what we call stop words. You get rid of what we call derivations from the stem of a concept, and you get rid of special characters. Why? Well, stop words are such words that they may draw meaningless connections between other words, so we don't want them, such as in Spanish articles, él, ella, words like para, por, etc. None of that is useful. Special characters, because a person may write a word in the proper form and the person may misspell it, and still they refer to the same word. So you don't want to constitute 2 different words from that, but just one. And lemmatization, because we want the concepts, not the words. Concepts, so that you can have, in Spanish, for instance, tengo, tuve, tuviese. You will take all of that and you will reduce it to tener, and that will be your concept, and that's how you analyze this. And then you encode all that data as preprocessed into numerical vectors, which you can then turn into networks and matrices. Now, in this case, what matters the most is the n-gram matrix, which is a matrix of co-occurrence within an n-word window. And co-occurrence networks we will be drawing for the final submission. The key difference between these matrices and the proper networks is that the networks show subtle connections or non-trivial connections of concepts. These matrices, this is not important, these matrices will allow you to see trivial connections. For instance, you have a trivial connection between Gustavo and Petro. You have a trivial connection between Constitución and deber. But you do not know from these matrices if there is a concept mediating the connection between another couple of concepts. So, for instance, in this case, since the window is 2-word, you would have no mediating word, obviously, or concept. But here, in a 3-word window, you will might, because you are taking into account 3 different concepts. However, the matrix is 2-dimensional, so you are losing that non-trivial information. We will put that into the co-occurrence networks, not this time. And in closing, I want you to notice you have to choose the word window properly as to grasp the most subtle concepts, associations, yet not so big that you will catch a lot of noise. Here, for instance, you can catch some subtle associations, such as between público and problema. You had none of that before. Why is that? Well, because some ideas take longer to develop. You need to regard a bigger number of words to catch an idea properly. And that's what we are calibrating here with the word window. Thank you very much.
Okay, so, but we are, who these guys are, Ivan?
It says group number 5.
Yes, so it's Manuel, Ivan, and Mark. So, but this is only the network?
No, what do you mean? I mean, that's the matrix.
Yeah, but the matrix represents the network?
Well, not proper. If you'd go a bit towards the beginning of the video, even a bit prior, yes, there, proper. So That's what we understand a co-occurrence network to be. And what that is a concept linked to, if you will, some sort of a cloud of concepts. In this manner, you can catch an idea of what the associations are within a text.
Yes, yes, but what you intend is, by these metrics, from these metrics, rather, you will construct this type of network. Is that what you're doing?
Yes, yes, teacher. In the last image, we represent that network not like others visually with connection and edges, but with a matrix that in this case is equivalent, and our next step is build a network representation from this matrix. That
This is
is also
okay,
a representation of the network.
this could be thought of or seen as the adjacency matrix, right? That represents a graph in general.
Exactly, teacher.
Okay, Professor, but yeah, we're just getting to the network. I understand because you want to relate the concepts from the text. Okay,
Yes.
Professor.
Okay, what I understood is that the network it's a better representation than those matrices.
Yes, yes,
superior
precisely. Thank you.
because it could detect new correlations.
That's right.
These networks are very important today. These knowledge networks are very important. I think that ChatGPT uses a lot of these concepts to understand what we say to ChatGPT. This is these are analysis. The Ngram methodology was used by Google and was used 5 to 7 years ago, but now these co-occurrence networks are I think are more efficient and can capture more knowledge. It's an interesting project. Your next step is the construction of the network and the analysis. Okay.
Yes.
Okay.
Yes. What type of analysis do you have in mind? Once you build the reconstruct the network.
So what those matrices are is, I mean, indeed, like you take each paragraph and you deconstruct it into sequences of words, of n words, which is from where the ngram thing comes from, and then you build indeed an adjacency matrix in the sense that you take every pair of words within the window and you strike them as coincidental within a sequence of n words, and then you take the entirety of paragraphs, the entirety of n sequences of words, and you take the number of times any two words co-occur within a window, and that's what you have on those matrices.
Okay. Okay. Good. Yes. Yeah, and it's very state of the art.
One last question. You have any problem with El Espectador? There was no availability of the data?
Yeah, so that's very unfortunate, but that's the current state of the media. You have to pay in order to access to any article, so we couldn't use it as we wanted to.
Okay, got it. Yes.
Yes, but because the subscription needed.
Okay, but anyway, with El Tiempo, you could obtain similar results.
Similar, but
okay.
Still you need. There are some articles that are restricted. You need to pay.
Yes, the many.
Okay, very good. Okay, I think we can move on.
Thank you. Nevertheless, before we move on, I would like to make a request to you two professors. So we had I mean, Classroom said the submission date for this assignment was Friday, and
that's my mistake. Actually, it wasn't. I think for some reason, I didn't update the year. It said 2023. Yeah, one of the one of the students emailed me, and then I changed it. I corrected rather because
Yeah,
yeah, was
and because this because this we had to run yesterday because for sure because we thought
yeah.
that
I think we
the
can do
deadline
that,
we have to
Professor.
do
Right?
it on
Maybe update
Friday.
the report if you need by Friday. Okay? Because yeah, I acknowledge my
Thank you.
sorry.
Thank you very much.
No,
Yeah, that was the point.
Sorry about that,
thank you
guys.
very much.
For everyone, if you need to update the report, so you can do it by Friday. Okay? Thank you, thank you, and sorry for the inconvenience.
Yeah, no problem. Proper.
Thank you.
So now we are moving to team number 6.
Hi everyone, we are the team number 6. We are conformed with Paula Jimena Rodriguez, Juan David Ramos, and Pablo Andres Guevara. We will talk about of the social network. In this case, we will try to talk about of the topic of the social networks and their incidents. Next, please.
Cases of study. Information diffusion on social networks using a large-scale anonymized social network dataset obtained from the Koblenz network collection. Network structure. The dataset we will use contains 2,887 nodes and 2,980 edge. Observing the number of edge relative to the number of nodes, we can notice that the network has a less dense structure with relative few connections between the network's nodes, suggesting that the network may be of a more diffuse nature. The above distribution shows that there are a number of nodes with few connections, whereas only a handful of nodes will have a large number of connections. This suggests that there are many nodes in the network that are only connected to a single other node and are not well connected to the rest of the network. Network science method. We use clustering. The network has a scattered structure with few dense clusters and more isolated nodes, which are not well connected to the rest of the network and therefore have a low clustering coefficient between centrality. Calculating the shortest paths in the network that passes through a node did with output the node with the highest between centrality, connecting separate clusters of regions in the network. This node is 603. And degree assortativity coefficient, we obtain a value of minus 0.668. This tells us that the network is characterized by a more modular structure wherein nodes connected to other nodes that are more distantly related rather than the other immediate neighbors.
The data life cycle. In this part, I will try to explain how we came to work with the interaction of the data and its results. At this point, I will explain in a very generalized way how the respective interaction of the data. The first 3 points, that is the enterprise level understanding, comprehension, data preparation, is about of the how we understand all the information that we have of the social network. The next point, that is the modeling, it means that we try to understand all the data sets composed. The next point, that is the assessment, is upon concluding the analysis, it's the network and the relationship with the dense structure with relative spare connection between nodes and edge. And the last point, that is deployment. In this point means such findings suggest the tendency with the social network data sets for nodes to connect. Furthermore, assessing to the significance of individual nodes within the network can be a keying throughout between centrality. Next.
Now we're going to explain another analysis that we did. We extract another data set from the same source that we mentioned before. And here we are loading the graph with the information that we got. After that, here we are showing the degrees. We are also showing the social network clustering for this other case. And we are computing here the between centrality. And also the assortativity, which is 0.12 in this case. Here we can we can see that the number of connected components are 246. Here is the topology, and we also note that there is a main component here. So we remove the other ones and we only select the main component. So this is the one, and we also compute the between centrality for this one and the clustering, and finally the assortativity. And here we can see that the assortativity is very close to the one of the main graph. And finally, this is the bibliography. Thank you.
Okay, let me just silence this and move browse here. Professor.
Okay, a very good project. Social networks are very important. I am perceiving that you have fluency with NetworkX. You have analyzed the network in NetworkX. One question: the goal of the project is to analyze the diffusion in the network, the type of diffusion.
Yeah, that's the idea. But for this task, for the progress report of today, we focus more on analyzing and understanding the data.
Okay, so you choose the appropriate parameters. Assortativity is a very important measure for diffusion and between the centrality, etc. This network is it's from Twitter. It's from no.
Actually, we know that this comes from the Koblenz collection, but there are two data sets. The first one is clean, so we are not actually sure from what social network is, because there we can find a lot of data sets from different social networks. But the exercise that we did at the end, this one is from another dataset that we extracted directly from the same source, but this data is not cleansed, and it's from Twitter. So,
What was the reason? What was the reason to do it on a different data set? I mean, this amount.
because the first one, as we explained in the report, in the first one we only have that, like the nodes and the edges. So we can build the network, right?
Okay.
But we don't have any more information like let's say the hashtags, the
Replies.
people. Yeah, we don't have a lot of information for the first one. So that's why we wanted to extract, and as we show here, can you please move a little bit forward? Yeah, the main component also shows a different structure, and as we show, also the assortativity is different from the other one. This is actually a little different from the usual social network, right? Because on the social networks, it's more like the assortativity tends to be negative, right? Because we tend to see that the nodes with less edges tends to connect to the hubs. And for this case, it's not the case. So the idea is also for the next task, we think that we have to also extract more and also analyze other networks, because in this dataset we find that there are 973 networks, and this was just one of those. So we intend to analyze, let's say 10 or 15, and try to be what are the main, how similar are they?
But one and teammates. What are the conclusions so far regarding the analysis? You haven't gotten that far on this particular network. Any results or comments or discussion about the analysis that you have performed so far?
For now, we just understand a little more about the network.
The network.
But yeah, but so far we don't have any conclusions yet regarding the diffusion on the network.
Okay.
Okay. I have one final observation. It's very important to know the semantics of the network. For example, if it's a network of political blogs, if it's a network of people talking about football, if it's a network, because if you're going to study diffusion, the conclusions have to be related with the semantics of the network. If you do an analysis to an abstract network and you don't know what is the semantic, the conclusions are very general. I don't know if you understand me.
Yeah. Actually, that's one of the reasons why we should be on the other dataset, because on the first one we don't have that information. So in the second one, for example, we have that some of the tweets have the hashtag like iPad, commute, sunset, Oscars, something like that. So we also intend to analyze what is the main topic that are there.
Other thing that we can to say about the conclusion or topics or main topics that we can to say is that relationship that exists with the users between the several topics that is a strong relationship by common things. However, this cool to join the relation specific in this social network.
Okay, so then for the next report, you will tell us the conclusions are regarding the diffusion, right?
Yeah, that's the idea. That's pretty.
Diffusion on the network. Okay? Regarding diffusion on the network. Okay, very good. Any other professor?
No, no.
I guess not. Okay, so let's move on to the other team, team number one.
Everyone, today, diving into the exciting world, marketing viral, with my group, Johanna Juan. Our main goal in this project is to explore social network through the lens of the network science, with a specific focus on understanding their importance in recommendation network for the marketing purposes, including leveraging the potential of the viral marketing strategies. We believe that social network can serve as a powerful mechanism to enhance marketing strategies through
Sorry,
network.
yeah, I guess it's not showing full screen. Is that Laura? What's happening? Laura? 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 Yeah, I don't know if is it me or is it
It's you. It's you because the video.
I'm sorry. Let me try this again. Yeah, sorry. Yeah, you're right. But I don't know why it's not showing.
Everyone, okay.
Now it is. I'm sorry. I rewind it. Yes, that's what you were going to say, right, Laura?
Yes.
I'm sorry about that. Okay, let's rewind.
Everyone, today, diving into the exciting world, marketing viral, with my group, Johanna Juan. Our main goal in this project is to explore social network through the lens of the network science, with a specific focus on understanding their importance in recommendation network for the marketing purposes, including leveraging the potential of the viral marketing strategies. We believe that social network can serve as a powerful mechanism to enhance marketing strategies through personalized and efficient recommendation system. We delve into the data. We have been analyzing our data consists of the 403,394 notes and 3,387,318 8H, representing the network deriving from Amazon Go purchasing data. Here are some important statistics we have observed. Now, let's explore analysis of the example here representing on the 30% of our data set. This sample consists in 100 for 100,000 notes, providing us with a more detailed view of the underlying network. In analyzing this sample, we calculate the average day degree, which is a measure of the connection of the nodes in the network. The result of the 1.65 indicates that on average, each node is connected to approximately 1.65 other nodes in the network. Additionally, we generate a histogram of the nodes, the grades in this sample. We observe that majority of the nodes have a degree of 1, suggesting the most products are related to limited numbers of the other products in terms of co-purchases. However, we also observed a few nodes with a degree of the 14, indicating certain products have a stronger connection with the variability of the other products. This analysis helps us better understand the dynamics of the relationships between products in our network. Okay, finally, we calculate the density of the network, which watching in the screen. We find the network is relatively sparse, suggesting that not all possible connection between products are represented in the sample. Now, let's to preliminary results obtained using subset represent on the 0.03% of the dataset. We applied node encoding with the node to big algorithm. In our analysis, we calculate the cause similarity between select nodes embedding. For example, the causing similarity between node 0 and node 10 was found at 0.87, indicating a high degree of similarity in their embedding representation. Similarly, in the causing similarity between node 0 and node 10,000 was 0.51, suggesting a moderate degree of similarity, while the similarity between node 0 and node 10,849 was 0.727, indicating a lower level of similarity. Additionally, we generate principal component analysis (PCA) and T-distribution distributed stochastic neighbor embedding graphs to visualize the embedding in lower dimensional space. These techniques allow us to capture and represent the relationship between nodes and in a more interpretable format, facilitating further analysis and interpretation of the embedding results. um, we conclude our project with these conclusions. The proposal is to extract a personalized recommendation system that align with the user preference and social interactions. The average degree of the 0.56 although the relatively low suggests that on average each product is co-purchased with the slightly more than half other products. Node too big is a node embedding technique that effectively represents the structure of the network data to produce low-dimensional vector representation of nodes. However, the challenge lies in effectively modeling the graph as if is computationally demanding. Thank you for watching.
Okay, let me just silence this, Professor.
Okay, I have one important observation. I guess the title is not current with what you are going to do. It's Don't worry, it's not a big deal. I understand that you're going to do predictions in a co-purchasing networks like networks of Amazon. Let me please go to the conclusions. To the first conclusion that I guess is okay. Extract personalized recommendation systems. Okay, I guess I'm not sure, but I guess that what you want to do is have to do with recommendation systems because the network you are using is co-purchasing network, and I guess it does not have to do with viral marketing. As I understand, viral marketing is how can I, if I have a product, how can I do it to maximize the diffusion for that everybody knows the product, for that everyone is going to buy the product, and all this is an objective, an important objective. If you have a product, how you can sell it to maximize profit, etc. I guess I'm not sure, I'm not expert, but I guess that is viral marketing. I guess the project is more about recommendation systems, and you are going to deal with very important concepts. Node embedding, it's a very important topic that you are going to study. We have not studied in the course, but it's now a very important strategy for analyzing a network and for preparing a network for machine learning. So I guess I don't know
Yeah, Professor, if
what
you
you
are
are trying to do. It's not viral marketing, but I guess the only thing you have to do, I guess, is change the title and no more and go. I don't know. What is your
yeah,
opinion
but
about
I think you made a point, a very important point, because yeah, I was also maybe just for the let's see, they are Laura, Johanna, and one Sebastian. Just maybe focus or rather explain it to us, to everyone, what is the actual goal. You know, if you have the network, like I think this is the only place where we can see the networks, right? Like these are two ways to show the networks, right? This is, for example, one way to show. This is your network, isn't it?
In this case, it's like a little sample of the network because the data it's really big.
Yeah, but this is your network. It's like if I look at the network, how do you how do you analyze it to try to recommend? You know, for example, as Professor was saying, what to buy. You know, based on the purchases. You know, what based on what other people have bought. And by the way, just before you answer, maybe you could tell because who was it? Sebastian Campino. He asked you guys what this is. What this is. What is this? What does mean? Well, he says, well, what is the? He asked rather that you guys explain these two graphs. These are just ways to display, you know, the networks, right, guys? Can you explain it to him and to everyone? You know, TSNE is one method to do that.
In this case, I have to say that this is like I don't know how to say, like a preview of the graph, but we have to do another task that we haven't done yet. That is like the prediction. So we're gonna identify some communities, and we're gonna put it in these plots. But in this case, we just want to show like the shape of the behavior of the graph.
Yeah, this is your wait, but wait. This is, you said PCA. Is that what I'm saying? I'm reading PCA, right? PCA. What does it stand at? Because the only PCA I know is the principal component analysis, but that's, you know, like you need to show if you apply that. Well, you need to show it in a vector space, you know, like continuous space rather. So I'm not so sure what are you showing there when you show PCA. What are you showing there? Well, unless the points are like actually on a vector, continuous space, a vector space.
Yeah, exactly. No, I just want to clarify a little bit before addressing that specifically. Yeah, first about what the professor said, the feedback. It's true. We might be confused about what is viral marketing in terms of we thought it was like doing this prediction of purchases instead of making a specific product viral. So yeah, we might be confused. So a better title, yes, it would be better to maybe say like recommendation network for purchases or something similar to that. First and second, given that fact, we want to predict if you purchase a product, what would be the product that you would purchase next to it? What product can you link after purchasing one, right? In order to do that, the idea is to first embed the nodes.
Yes.
So if you embed the nodes, it means that the graph becomes a set of vectors. But in order for you to do that, you need to apply an algorithm. And the thing that we're trying to do here in the progress we were trying to make in the for this delivery, it was trying to test different algorithms. For instance, node to vec.
Yes.
So Johan tried to embed first, and second, measure the distance between a product that is already embedded to see how it looks. So he painted that. He made this plot here that you see, and because of the time, we didn't have much time to test a lot of things because the network has almost, let's say, 3,000 nodes. And in order for us to get results relatively fast, we had to use, let's say, like 3% of the data set, if not less. And that's what you're seeing there. The plot that Johan became with lately to compare embeddings of products to see the distance between a node that has been embedded as a vector. That's more or less like what we did.
Yeah. Okay. Yeah, it makes sense. Yeah.
Okay. I have one final observation according to what you have just said. If you are going to reduce the size of the network, you have to be careful because you have to preserve the co-purchasing. You have to preserve the structure of the network, and in this case, it's very important because the network has a specific semantics. It's the nodes are the edges are between. There's a net between two nodes if those two persons buy the same article. If you reduce the network in a random way, you could destroy the semantic of the network.
Okay.
There are in the literature there are various ways to reduce the network and do not lose important properties. If you have any doubt, you can email me and I could tell you about that.
Yeah, because what I see, Professor, is that they are actually like just embedding the points, but they are losing they are not keeping track or preserving the connections, right, Professor? Just the nodes.
Okay, but you can embed the network, you can embed before reducing. You can reduce and embed, or embed and reduce.
But what I'm saying is that in this case,
if you embed and then reduce, I guess there's no big problem.
Okay.
Yeah, what I'm saying, Professor,
but if the network is very large, the embedding could be, I don't know how much time it Node2Back is a very fast algorithm. Node2Back is a very simple and very fast algorithm. But if you reduce and then embed, it's not commutative, okay? Reducing and embedding and okay.
Makes sense.
Anyhow, you have to study a little bit that. It's not difficult, but it's important that when you reduce the size, you must preserve the essential properties of the network, okay?
Teacher, I got a little question. When we're gonna train this model with Node2Back, and maybe we could use a GPU to get faster results, because in terms of time, with all the data set, it's very it costs a lot.
Yes, I recommend that you first try to do the node embedding with the complete network. I don't know how much time it's going to take. If you have access to a GPU, pues it could be, and the best thing to do could be that with the GPU you reduce you embed, you do the embedding with Node2Back, and with those embeddings you have vectorize all the graph, so the problem of eliminating elements it's easier. But anyway, you could try and I guess with the GPU you could do it.
Yeah. Professor, what about taking an LLC, a subgraph of being the subgraph, a complete subnetwork that is completed? Because in one of the characteristics of this particular data set is that almost everything, it's not completed at all. Like the products are on their own, right? So what if we take like a subgraph being an LLC, completed, the largest one?
Okay, the problem is that if you reduce it to a complete network, I guess you are considering the people who buy a lot of things, who buy many things, and you lose the buyers that buy few things. I don't know.
Okay.
Really, I don't know. Really, I don't know. But you could assume we are going to study the big los grandes compradores,
The consumers.
the big consumers of Amazon, and we're to concentrate on that, and then you could reduce the network to a click or to a complete, and
Exactly.
and
Yes.
you have your objective. But if your objective is not the big the the great buyers, but the buyers like us that buy not many only books on Amazon and not houses or something like that, you could. It depends on what type of
Study. Yeah. You want to.
Okay. Understand.
Yeah, but yeah, it's a good, maybe it's a good way to proceed. Just take a sub network. And reduce the network, but depending on the type of analysis that you want to perform, just select the nodes and the connections that you are interested in, right? Yeah, but that's a way to proceed. Like just get there some network, and that's
Okay.
good, very good. Yes, yeah, I think interesting, very interesting though.
Thank you.
And we are going to. I only have this video. Okay, missing, I guess. And by the way, we have time. I think we need to stay with the professor
Daniel Muñoz,
with
Juan Arias.
these students from this team. Okay.
Hi there. We are Daniel Muñoz, Juan Arias, Daniel Garavito, and me, Farid Estepa. Our research project is about bibliometrics in the context of science network, so go ahead. We will divide this progress into four different phases: the definition of our objectives and scope, the selection of variables and methods that we will use in the study, detailing the data used, the preliminary results that we have obtained from the analysis, and finally the conclusion of these findings. The scope of our project is to determine the current bibliography on the study of networks in order to identify the growth process in the study of network science through cases. This will allow us to determine the most relevant keywords when searching for documentation, as well as to identify the most relevant authors who are the most cited, and finally, to understand the most common research applications. For bibliometric analysis, fundamental techniques such as performance analysis and science mapping are used. Based on the results of these techniques, we will use networks to determine clusters and network metrics. Performance analysis are direct studies focused on quantitative characteristics that can be presented. These are classified whether they focus on publication parameters such as the total number of publications and co-author publications. Another is focused on citations such as the number of citations, and finally a metric that relates the two previously mentioned characteristics, like the number of published citations and the collaboration index.
For science mapping, these are parameters of a more qualitative origin that can be interpreted as quantitative parameters because they examine the relationship between research constituents. The analysis pertains to the intellectual interaction and structural connections among research constituents. In this case, we have four different parameters. Citation analysis. These are relations among publications, most influenced publications. Co-citation analysis. These are relationships among citing publications, periodical or present of or them. Cohort analysis. Existing of future relationship among topics. And Co-authorship analysis, social interaction or relationship among authors, authors and authors of relations. Given the parameters previously discussed, it is planned to use networks to calculate the metric parameters, like degree of centrality, closeness centrality, between centrality, agent vector centrality, and page rank. And to initial generate clusters, it is planned to use optimal, Leuven, and Leiden. The data used was extracted from the bibliometrics platform, collecting a total of 46,837 documents, detailing 29 types of variables per document, including author, document type, journal, language, total of citation, abstract keywords, among others. For this occasion, the network analysis was carried out for the keywords, collaboration, and co-citation. The metric study of the network was carried out presenting the following metrics. Between centrality. This measure presents information about the role played by the research constituted in the network. Eigenvector. It reflects the importance of the node within the network that is the responsible for transmitting information to other highly connected nodes. PageRank. This can be used to calculate the prestige of the publication that influence the field of research by influencing highlight cited publication, despite not being highly cited themselves. And degree of centrality. It establishes the relationship that the parameter has had with him respect to other nodes. In the case of keywords, it shows how common is it to find certain keywords in the article or document, while for the parameter of collaboration and co-citation, it shows how frequent the participation or reference of the research in journal is.
Here we can appreciate the result of run different cluster algorithms. Optimal Louvain, Leiden, Infomap, Edge Between It, WorldTap, Spinglass, Leading Agent, and Fast Greedy. When calculating communities, very few or none were found in analysis of cocitation by author and cocitation by words, which should be reviewed and improved from future deliveries. The different results of community calculations for collaboration require a detailed review to identify which of the algorithms shows a better response or if different representations can be made for each algorithm. The data presented in the keyword cocitation, collaboration, and the cocitation by author tables are reveal interesting patterns of centrality in terms of keyword concurrence in collaboration and citation. Terms such as social network and complex networks and the listed authors show high centrality indicating their importance and relevance in the respective networks. Calculations with keywords have low confidence from the storage moment.
Okay, let me see the results at the end. Professor?
Okay, could we go to the first slide? No,
Which one?
the net objectives, I guess.
Ah, the goals, okay.
Goals.
Purpose here.
Okay. Identify the growth process in the study of network science through cases. Okay, this is very general, I guess. The second, rank the most relevant keywords for searching network science studies. Okay, I guess the last is the most important. Identify the most referenced authors.
Yeah, okay, I guess, Professor, the goals are actually, yeah, I think the first goals, maybe it's a matter of writing the way they wrote them, but I think, let me see. I was just looking for what they want to identify regarding the course citation, author course citation, reference citation, and let me see, what was is this one, right?
Okay.
These are what they actually want to do, right, guys?
Right, Professor.
And you want to compare these four analysis to compare or and to see what is the
Yeah,
or
the objective is to analyze the information we inspired by a previous paper and take it to this time because the paper is from 2020 and run other algorithms that the paper doesn't run. So review research what about those results.
okay, so you are going to use the same network that the paper uses, and you're going to complement the
Similarly, but we have to construct it because the network doesn't exist.
okay.
Only the network uh, was descripted,
Okay.
and we take the information or download the information from the science database, Web of
Okay.
Science, merge it, and construct a data set in R that we can analyze it. And some of the analysis was run by R or with R.
Are you going to do in R all the analysis?
In R, all
In
the
R, okay.
analysis, yes.
So you are going to use a iGraph? iGraph?
I, iGraph is
iGraph.
we at this moment we are using a library that behind runs iGraph. The
iGraph.
library calls bibliometrics.
Okay. So
Do you
it's
know it,
it's a
teacher?
specialized library that in the back it has it works with iGraph. Okay.
Yes. It generates graph objects
Okay.
that can be analyzed and printed with the others functions of iGraph.
Okay, iGraph is very similar to NetworkX. They are similar.
Yes, I think so.
Yes. So it's okay.
Okay, so the analysis is not done yet.
Yes, we focus on run the or get the data, structure the data, and run some algorithms, but we still doesn't analyze it because the time for a
Okay.
particular thing don't give us but we expect to do it and research some other forms that for example in this image in keyword citation running this specific algorithm optimal, we probably can get some better result that show us really show us a community. So because the library has some variables to manage the information, and the other thing is that we have a very large data set, but for our processing capacity
our PCs can manage so many information. So we have to focus the information or the data in some about I heard in this class that maybe we can use 2000 is a good data set, professor, maybe.
You have to filter the network.
Yes, so
Okay.
for filter the network because it works with 45,000 is a very large network that we can handle.
Okay.
Okay. Yeah. Collaboration. I was just looking at the networks that they already displayed.
Yes, Professor, the networks
So
are
no,
the same.
no conclusion so far because you haven't performed the analysis.
Yes, the networks are three networks at this moment. Those three networks that you can see, but running each algorithm is that we are showing in that moment, and the code we share have the procedure.
By the way, regarding the objectives, like I think you need to review these because they are not like so closely related to what you are saying. Like if they will be more precise, no, more specific to what you refer to here. Like
Yes, they are very general,
yeah,
specific.
they are very vague. Very vague, and they should be more precise regarding this analysis. Just you can restate them. Yeah, maybe the last one is the one that is the most closely related to what they are actually doing. Okay,
Okay.
Professor. I think we can stop here. Maybe I don't know some editorial regarding the projects, and if we could like spend a few minutes with this last team, just with them. But I think so far so good. Right,
Yes.
Professor?
Yes.
So far so good.
How many groups are left?
No, we are done already.
Oh, we're done. Oh,
Yeah, but we have like
no,
5
no,
minutes. Maybe
okay.
just some
I thought
editorial.
that there were more groups.
No, right? Just to make sure all the teams have their turn, right? Guys. Yes.
Okay.
Yeah. Yeah, but very interesting. So I don't know if you have any suggestions. I think
Yes, I have one or two observations.
you-
The first observation is the diversity of the projects. This shows that network science is a very interdisciplinary topic. Uh, we have every group has 3 or 4 weeks more for the
oh,
final.
yeah, by the way, regarding that, tomorrow we are going to post
Yes.
the instructions,
Yes.
the last deliverable, the final project report that is going to be so far. We agreed. Let me see just to make sure. May 15th, because we're going to have. Let me see just to make sure we are going to have a holiday in the middle, right?
Yes.
May the 1st is going to be a holiday in Colombia, so that day we are not going to have a class. Sorry about that. So we are going to have the final project presentation on May 15th.
Yes.
Yeah, maybe there was one team that needs to push it hard, because I think it's still behind, but in general, you were able to build the networks and perform some one type of analysis. And by the way, try to focus on whatever is the goal of your project, and if you cannot do whatever you proposed at the beginning, just leave it as future work. And it's important that in all the projects you state in the report you say what is done to be done in the future, to continue the analysis. Professor, you were going to say?
Yes, another important point, I guess, is if you have a problem with your small problems with your project, don't hesitate to send a message to me or to Luis Fernando in Google Classroom. We could have a meeting, a short meeting in Teams or in Google Meet. If there's a problem, I have Fridays in the morning. I have no classes, and I could in case be aware of if there is any problem. A year ago when we offered this course, there were 3 or 4 groups that talk with me and solve problems that they have with the projects. It's normal. So if there's time and if there's don't hesitate to write me. Okay.
By the way, I guess maybe I'm sorry about that, but we should have done it, but it's not too late anyways, because there is a discussion forum then that not only about the questions about methodological aspects for the project development. So you can always exchange that in that forum, between you guys, and ask for maybe general questions that may be of interest for everyone about the project development. So please feel free. It's posted there on Classroom. And I guess I'm sorry, it was maybe our mistake to have emphasize that it was available there, to discuss some of the issues regarding the project development discussion forum. So it's there on Classroom. So feel free to post questions there and maybe exchange information which can be useful, for other teams as well. Maybe now for this final assignment.
Yes.
Yes, so that would be interesting. I mean, just please feel free to do it there, and you can share, important information about, so the use of the software, or maybe about the measures, whatever. Maybe your question or your doubt. Sebastian.
Oh yes, I have a question. Like the Professor Alfonso, he said that there is like a book or something to filter like networks or reduce the number of nodes. So maybe can you share with us like those information, please?
Yes. You can, Sebastian, you can send me by Google Classroom. You can send me a message.
By the way, maybe there in that particular
forum. Okay. Yes.
Sebastian, and then we can post the answer there for everyone, because I think that's a very important
interesting for other groups. So Sebastian, if you could put your question in the forum that Luis Fernando is talking about, we could talk in the forum, and the information could be shared for all the group. So do it tomorrow or when you and we can talk in the forum and
yes,
how that is important. I guess that is important. This. Okay, perfect.
Okay, thank you.
Okay, thank you. I think we can dismiss the class now, and I'll ask two students and Professor Alfonso if we could stay for a few minutes. So,
okay,
team number 9, please, and I stop the recording the session just now.
Okay.
Good job, guys.